doing special polynomials. This time I'm not going to be talking about squares. I'm actually going to be talking about cubes. Yes, so x cubed is what we're looking at today. So I'm not going to actually prove these to you, but it's good to know, especially for some math contests. If you want to actually know how to do it, you're going to have to learn something called the factor theorem and the remainder theorem. That's usually taught in either your grade 11 or 12 course. So I'm not going to show it to you, I'm just going to tell you. So a difference of cubes in factored form is the following. It's x minus y in one bracket, and then it's also x squared plus xy plus y squared. Don't believe me? You can always double check this by distributing, and then adding the terms together, you'll get x cubed minus y squared, y cubed, sorry. The sum of the cubes, well, x plus y, and then same terms, x squared, but this time it's minus xy plus y squared. So the only things that are different are the signs here and here. Okay? So noticing this then, let's see if we can factor these 5 questions. Oh, I made a mistake here. It's not x squared, it's x cubed. Make that change, please. Sorry about that. X cubed minus 8y cubed. So once again, if you can see the different pieces, something cubed, yeah, x cubed, and then 8y cubed is the same thing as 2y all cubed. So now that I've found this out, I can plug it into the formula. This is a difference of cubes, so I'm using the one up top in blue. It becomes x minus the y value, in this case is 2y. And then it'd be x squared plus x times y. Once again, our y is actually 2y in this case. Plus 2y all squared. Be careful with the squaring. We want to square the entire expression. That's why I have those extra brackets. So I will simplify this now. X minus 2y, no problems there. X squared plus 2xy. And then 2y all squared is just 4y squared. That's it. Okay. Try part B now. You're like, these aren't cubes. You're right, because you have to factor the greatest common factor first. Take out a 2 perhaps, and then now you'll see 64a cubed plus 1. I think now we have a sum of cubes. In this case, the first thing, x, is the same thing as 4a, and then the y value, I think, is 1. Okay, remember 4a all cubed is 64a cubed. So we'll have the 2, and then now I'm going to use the sum of cubes formula, the one I'm going to highlight here in yellow. So here we go, x plus y. In this case, my x is the 4a, my y is the 1. And then my next bracket, 4a, and remember we have to square it, minus 4a times 1 plus 1 squared. And so now we can expand this out and simplify at least the stuff inside the second bracket. 4a all squared is 16a squared minus 4a plus 1. And there's our final answer. Okay. C is the same. So here I have a difference of cubes. Guess I'll pull that up so we have the formula again. The difference of cubes will be x minus y, so the first term for x is x plus 1 minus the y, so minus 2x. Okay, and I'm going to put this in a bigger bracket like that. That is just the first part, x minus y. And then we have x squared, so that's x plus 1 all squared, plus x, which is x plus 1, times y, which is 2x, and then plus y, which is 2x all squared. And of course, I'd like you to simplify this, so distribute, well, you don't have to distribute, it's only one thing, so x minus 2x is negative x plus 1. But over here, I'm going to try to simplify, I'm going to expand, that's x squared plus 2x plus 1. This I get to distribute 2x squared plus 2x, and then 2x all squared is 4x squared. And once again, let's see if we can simplify the things in that square bracket. X squared plus 2x squared is 3x squared plus 4x squared is 7x squared. 2x plus 2x is 4x, and then we have a plus 1. There you go. Okay. And then we'll take a look at D. This one's a sum of cubes. Once again, there's my x. Here's my y. So once again, just applying it into the formula. Here we go. It's x plus y, so m minus 2n plus m plus 2n. And then we have x squared, so that's m minus 2n all squared, minus m minus 2n times m plus 2n, and then plus m plus 2n all squared. Woo! I think I need more space. Well, at least we'll simplify. Okay, m plus m is 2m's. So this just becomes 2m. Negative 2n plus 2n is 0, so that's good. And then now here, we can expand this out. M squared minus 4mn plus 4n squared. Here I'm going to distribute, I know this is a difference of squares, so that's just a squared or m squared minus 4n squared. And then over here another perfect square, m squared plus 4mn plus 4n squared. Woo! Oh, lots of m's and n's. Distribute this in, right? That negative sign. Notice I can now collect these terms. So I'm thinking m squared minus m squared. Oh, that's good. That's nothing. Oh, I still have an m squared there, so I guess that's m squared. Negative 4mn. Another 4mn. Good. They disappear. Yes, that's great. Then I have 4n squared. This two negatives become a positive, so that's really 4n squared plus 4n squared is 8n squared plus another 4n squared. That's just 12n squared. There we go. And that's your final answer. Okay. Alright, and we'll save the best for last. What? What is this? X to the power 6 minus y to the power 6? I don't have a difference of powers of 6 formula. How can I even do this? Well, we do have a difference of cubes formula, so can I rewrite this as a cube? I hope you can, because I can. X squared cubed minus y squared cubed. Ah, now I've produced a difference of cubes. And I can use my formula, so x minus y, so in this case x squared minus y squared. And then I have, once again, x squared, so that's x squared squared, plus x, and then the y, and then plus y squared. Nice, nice, nice. Hey, look at this. Difference of squares. I can factor that as well. Hope you remember x plus y, x minus y. And then here, I guess we'll just have x to the power 4 plus x squared y squared plus y to the power 4. And that is it. Whew. But wait. For this particular question, who said we had to make it a difference of cubes? Couldn't we do it like this? Why don't we write it like this? X cubed squared minus y cubed squared. Couldn't we do that as well? So the alternate way is to write it as a difference of squares. Difference of squares. And now this is a squared minus b squared, so a squared plus b squared, sorry, a plus b, my fault, and then a minus b. There we go. But look what we just created now. Oh, look. Sum of cubes. Look. Difference of cubes. Dun, dun, dun. The sum of cubes. X plus y times x squared minus xy plus y squared. Difference of cubes. X minus y. X squared plus xy plus y squared. Right? And if I were to move this to the front, x plus y times x minus y, I can then just reorder this. And you're thinking, shouldn't this be the same answer as the one on the left? Aren't these the same? Well, they don't look the same, but I am going to tell you they are. Why do I know they are? Well, let me just do a quick little expansion now of these terms. We're going to distribute, okay? Watch as I distribute, okay? The first term, x squared, gets distributed into all three of those next ones. So x to the power of 4 plus x cubed y plus x squared y squared, okay? Then the middle term gets distributed into all those three. So negative xy times x squared is negative x cubed y, negative x squared y squared, and I see negative xy cubed. And then finally, I'll use black. The y squared gets distributed in all these terms as well. Running out of space, I'll put it down here. Plus x squared y squared plus xy cubed plus y to the power of 4. And now if I were to simplify, once again I have x plus y, x minus y, but now look, I have x to the power of 4. And look, x cubed y minus x cubed y, bye-bye. X squared minus x squared y squared, bye-bye. Negative xy cubed, positive xy cubed, bye-bye. And so you're left with x squared y squared, and then y to the power of 4. Yes, it is the same. So when you're doing x to the power of 6 minus y to the power of 6, you can do it both ways. Start it off as a difference of cubes, or start it off with a difference of squares. You'll get the same answer in the end. Alright, that's it for factoring. I'm sure you're factored out. I am too. So practice these things. Like I said, you're going to use this a lot in senior level math courses, so make sure you know this skill really well. Bye for now.